So this webinar is called Generative AI for Developers, as you can see on your screen. Our speaker today is Mr. Pawan, who is a developer advocate here at Single Store and has extensive technical experience in terms of software and has worked in the software space. Pawan, please correct me if I'm wrong. For a lot of time, and now he is sharing his experience as a developer advocate, and he enables developers to use single store and solve their issues whatever they are experiencing with the use of single store db. So yeah, today's webinar will be like I think it will cover the basics of generative ai and how to implement it in your use case. And yeah so Pawan, thank you so much for joining us. And for everyone that has joined us live, I have one announcement to make. For everyone that signs up using the links that we will give, like, so that you might see that there's a Q&A button that's present at the bottom of your console, and there's also a chat button. So I'll be communicating all the links, resources that is essential for this webinar using the chat button, and you're free to utilize it and have a hands-on session, which we highly recommend, because towards the end of the session we will be having a dedicated Q&A session, which will be of about 10 minutes, where Pavan is going to answer all the questions of the audiences. And it's like our agenda to answer all the questions that the audiences have. So even if it's a simple question, or even if you think that it's not relevant, please feel free to ask away. We might even follow up with you all with over email. So yeah, uh, one more thing, we have a free generative ai ebook that we will be doing a giveaway uh, for all the people that sign up. We will be sending that ebook to them once we validate that within our records. So yeah, Pavan, I think you have that ebook with you. So once he shares that with me, I'll be able to like communicate that with you. So, all right. Pawan, please
Yeah,
take it away. And thanks so much for joining.
sure. Thanks, Yukti. So let me share my screen. I just shared the link to sign up and get the free ebook.
Yeah,
And
I will
let's
share
share
it
my
with
screen.
the audience.
Sure. My screen is visible, right?
Yeah, it's visible.
Okay, sure. Let me... Hey guys, thanks for joining today's session on generative AI for developers. So I know many of you heard about generative AI, why many of the companies and enterprises now moving to creating generative AI applications and agentic applications. So yeah, let's start. So who am I? My name is Pawan Belgati. Like Yukti mentioned, I'm a developer evangelist at Single Store, and apart from that, I write a lot of articles on generative AI on different concepts and topics. You can follow me on LinkedIn. I'm very active on LinkedIn and one of the top voices for that reason. And yeah, so let's get started properly. This is the agenda. Today, I'm going to talk about AI systems. And I'm going to talk about the AI layers, right? What are the layers under AI? AI is a whole big ocean. So what are the layers? And particularly in that layer, we're going to talk about generative AI. We'll talk about machine learning, and we will talk about how Gen AI models are different from machine learning models. And we'll talk about how Gen AI basically works, and we'll talk about some Gen AI tools. And of course, we're going to talk about touch base, what are large language models, and we will talk about RAG, retrieval augmented generation, and we'll talk about vector databases, semantic search, and at the end, I will also show you why you should use single store as an all-in-one database compared to just specialized vector databases. So let's get started. So yeah, when it comes to AI systems, we have been using Alexa and Siri at our homes for a very long time, but we didn't know they are actually the AI systems. Sorry, there is a festival going on in India, so there is a little bit of disturbance, but hope that's okay. So yeah, coming back to the AI systems, we have been using these systems like Alexa, Siri, and at our homes for a very long time. But you might ask how these are different from Gen AI systems, Gen AI tools. The Gen AI, the name suggests, right? It produces something new. It generates something new. Whereas these traditional AI systems perform very specific things that the engineers have fed them. If you ask a particular thing, the output will be similar, and most of the time it's the same thing. They don't produce anything new. They don't generate anything new, and that's where traditional AI systems or tools basically fail compared to Gen AI systems, right? So coming to the AI layers, so we need to understand there are different. AI is a big word and it's a big ocean. And under AI, these are different layers we need to understand, right? Under artificial intelligence, we have machine learning, and under machine learning, we have deep learning. And under deep learning, that's where we are like, we will see generative artificial intelligence, what we call Gen AI. And under Gen AI, we talk about large language models. And in particular, we talk about GPT, the generative pre-trained transformers, the chat GPT, what we call. So this is a big layer, just an overview of the different AI layers, right? So yeah, the rise of Gen AI, right? If you go to Google Trends and try to search for this particular keyword Gen AI, this is how it is growing. I mean, this is little old data, but I just wanted to show you that how after ChatGPT AI, before ChatGPT AI was just we thought like only experts can use AI and they are very well known with AI. Only they can use those tools. But after ChatGPT, we saw a huge surge in Gen AI applications. Everybody started using ChatGPT. That's where you can see now it's after 2023, it is growing up and above because everybody now wants to create some type of Gen AI application, right? So under AI, the second layer is machine learning. So we should also understand, what is machine learning. So machine learning is basically, like we saw, it's a subfield of AI, and it gives computers the ability to learn without basically explicitly programming, without programming. How does that work? So there are basically three learning things like supervised learning, unsupervised learning, and semi-supervised learning. So supervised learning is where it goes with the labeled data because there is an expert who will show the machines or models that hey, this is dog, this is the image of a dog. So only discrimination happens there. If you tell that model, it'll just pick. If you show the image, it will just say whether it is dog or not. And then in unsupervised learning, there will be no any labeled data. So the machines learn without any labeled data. They just pick the patterns and sense the patterns and group the things. So that's how they usually learn. And in semi-supervised learning, it's basically, as the name suggests, it's both, but most of unsupervised learning and less of supervised learning. That's what happens in the semi-supervised learning. The And that's how usually the machines usually learn. And then under machine learning, we saw deep learning. So what exactly is deep learning? It's a specialized type of machine learning that uses artificial neural networks, as you can see here, right? It basically represents a human brain. Nobody knows what goes inside with multiple layers to analyze data and basically learn different complex patterns. And you will have an input layer, multiple hidden layers, and then there is an output layer. That is what deep learning basically is all about, which comes under ML. And we saw these neural networks, right? What are they? So neural networks basically help you predict the next word in a sentence, right? In a sequence of a sentence. For example, cat sat on a, so mat, it can be something else. So as you can see, it basically predicts the next word. And here the probability of the next word is 90% only. I'll tell you why it's only 90%, why it's not sure of 99% or more. So that's how neural networks basically work. And excuse me. Yeah. So if you open your message app and if you try to type in like hello, and then it will basically tell you the next word, suggest you the next word. And if you try keeping pressing the next word, and this is how you will get, right? Hello, how are you feeling this week? And your kind wishes for a certain time, you feel like, yeah, the sentence is forming properly, but after a certain time, you feel it doesn't make sense because there is no context here. So that's where neural networks usually fail. So that is when folks from Google came up with this research paper known as Attention is All You Need, because previously these neural networks did not carry any self-attention mechanism. That's where Google, the folks from Google proposed a new simple network architecture, the transformer architecture, based solely on attention mechanism and softmax activation function, which can not just do feed forward, just like we saw in the neural networks, but it will also carry the context further to make a lot of sense, right? So this is how transformer model basically works. If you say write a story, it will start with once, and it'll take that as an input and produce the next word, once upon a time. So there you see a self-attention mechanism, and more context is preserved here. Again, the same thing, right? That how the transformer model basically works. My name is, so it will take that output and takes back the same thing as an input, and tries to make a sentence with the proper context, right? So with almost 99% accuracy. So how traditional neural networks are different from transformer model? As you saw in a message app, the neural network, it just does a feed forward. It doesn't produce anything new. Whereas the transformer model tries to produce or predict the next word, right? Tell me a story. Ooh, so once upon a time. So it basically tries to predict the next word and builds a proper context and then produces a story. So yeah, and under deep learning, that is where generative AI comes into the picture, and that's where we are all most interested in, right? So what exactly is generative AI? It's a type of artificial intelligence that can produce various types of content, right? Why we use ChatGPT? Now it produces text, image, and all those sorts of things. And generative AI is again, like I said, it's a type of AI that can produce various types of content, including text, image, audio, video, synthetic data, and anything. So as we saw, right, with OpenAI, we got GPT, DALL-E, Codex. GPT is where we use it for creating content, text, and then DALL-E is mainly for image generation, and Codex is for code generation. So that's a simple way of understanding generative AI through OpenAI. And this is how ML models are different from GenAI models. So as you can see, the in the ML model, it learns the relationship between data and the label. That's it. It'll tell, like if it's dog, it'll say yes. Otherwise, it says no. Whereas in a GenAI model, it learns the patterns in the unstructured content. Basically tries to produce a new content itself, right? It doesn't just discriminate, say differentiate between, like, yeah, this is dog or this is cat. It basically generates a new content. So that's the capability, and that's the difference between ML models and Gen AI models. And we have come a very long way from traditional programming to neural networks to Gen AI, what we see today. So, what used to happen before? Developers used to hard code everything. If they want to showcase or mention cat in any program, they used to hard code, like type animal legs 4 ears, two likes yarning catnip. So, and then we moved to the neural networks thing, where we started. Labeling everything. Yeah, this is cat. This is not a cat. So that's how machine started learning things. And now what we see is generative AI models like Lambda, Palm, GPT, everything. So if you tell that model, hey, go read this huge pile of books about cat and generate something new about cat, like write an essay about cat, it can basically generate that. Even it can generate an image of the cat. So that's where we are today. And this is how GenAI basically works. The traditional AI was mostly of the discrimination model type, like, is this a dog? Yes, this is not dog. So that's how it used to do. But then now we move to GenAI, where the trained model, the model is trained on various sources, structured, unstructured data. And if you ask a prompt like, what is a dog? It can actually generate, it can actually answer, not just discriminate, saying, yes, this is dog or not, right? So coming back to the large language models, so generative AI applications are built on top of LLMs. right? So if you ask a query, it goes to an LLM and you get a response. So that's it. That's the thing. Like how we use ChatGPT, you can select different LLM models there, and you can basically ask a query, and you will get a response. As simple as that. But what exactly the components of large language models? What are they made up of? Data, structured, unstructured data. It can be anything from Wikipedia around the globe, right? Around the internet, audio, video, YouTube videos, Wikipedia pages, all those things. And then architecture, the transformer architecture that we saw, and then some kind of supervised, unsupervised training. That's how you will get an LLM model. And and you can use these LLM models to adapt to different tasks. For example, creative writing, question answering, text summarization, translation, sentiment analysis, interactive conversation, and information retrieval. So and I got this from Andre's video, like how LLMs learn, right? So the first thing is pre-training. You download 10 TB of text, can be structured, unstructured data, all right, and get a cluster of 6,000 GPUs and compress the text into neural network, pay this much and wait for 12 days, and then obtain a base model. So that's when you obtain a base model, and then you just have a base model which can basically make a lot of mistakes. But then now you need to fine tune that model. That's when you start writing labeling instructions, and you hire people like AI engineers, ML engineers, right? And then you fine tune that base model to on the data that you require, and it will take almost 1 day, and you obtain an assistant model after that, and run a lot of evaluations to see if that model is predicting the proper responses, and then you deploy, and then you monitor it. You basically collect all the hallucinating behaviors, misbehaviors that the LLM is doing, and then you go back to the step one again. So basically it requires a lot of amount, I mean money and effort. So to build an LLM and to make an LLM learn. So this is how the ChatGPT training process takes place. Uh, 1 second. So you have so they have collected internet text data and document data around the everything what they have seen from the internet, and then that's where you get the first stage, generative pre-training. The pre-training happens. You get the base model of GPT. And then the second stage is supervised fine tuning. That's where a human expert AI trainers come into the picture. And then after that, you get a fine-tuned chat GPT model. And then in the stage three, you do reinforcement learning, right? That's where experts, they enforce the learning and they make sure you get a chat GPT model, proper model at the end. So these are the simple steps where you get GPT model and fine-tuned chat GPT model, and then chat GPT model at the end, right? And but these LLMs, what we saw, they have these limitations, right? They have the missing context. What if you want to use these LLMs for if you're working in a healthcare sector? They don't understand your vocabulary. They're not tailored, and they don't get you the tailored outputs that you want, right? So sometimes these LLMs produce, you know, uh, the responses that you don't expect, the made up answers they produce. So this behavior of LLMs is known as hallucinating behavior, and they basically produce hallucinating answers which are not proper to use in your AI applications. So and this is the hallucination leaderboard from Vectora. I got it some days back. Like GPT-4, as you can see, the answer rate, the hallucination rate. So 3%, and GPT 3.5 is 3.5%. Llama 270 beats 5.1%. So accuracy also you can see. So what are the possible solutions to eliminate these limitations of LLMs, right? So one is fine tuning, second one is prompt engineering, and the third one is retrieval augmented generation. So let's look at them one by one. So fine tuning is where you take the base model and you add your custom data. You train the model with your custom data so that it starts understanding your vocabulary. As you can see here, base model, you just tell, like the prompt is tell me how to fine tune a model. It just give you some completion type of answers, responses. But when the model is fine tuned, as you can see now, right, the prompt is tell me how to fine tune a model. If you ask that query, it can basically give you a proper answer, right? So that's about fine tuning. Fine tuning basically requires a lot of effort and there's a lot of computing power required. And yeah, again, this is about fine tuning, right? You add some, you train that base model with your domain specific data set. And that's how you get a trained, fine tuned LLM. And prompt engineering is where it's an art and science of working with your prompts and seeing the output and making sure adjusting the prompts basically. Nothing much here. And and the third one, which is almost the recommended one, the retrieval augmented generation is what we call. This is where you augment your custom data. You basically give your LLM the context that is required to through a vector, through a database that's known as vector database. That's how when a user query comes and it can easily go through that vector database to find the relevant chunk and give you the response back, right? Give a proper contextually relevant response back to the user. And this is a simple RAG example, right? The question, it basically goes through the vector database to find the relevant chunk. And now again, now you have all the context and it goes through an LLM model to finally give you the response back, right? Contextually relevant response. And when we talk about RAG, we also need to talk about, and Gen AI, we also need to talk about vector database. So in a vector database, this is how the representation takes place, like in the form of vector embeddings. The dog can be represented like this, and the puppy can be represented like this. And the similar words are grouped together in a vector database in like a three-dimensional or two-dimensional space. So for example, right, if you go to Postman, the API tool, and if you use OpenAI embeddings, text embedding ADE002, and the input is hello world, as you can see below in the form of numbers, 0.007523.015. So that's how uh, embeddings are created for a particular input. You can change the input and you can see the embeddings, different embeddings, right? So this is how they are grouped in a two-dimensional space in a vector database. And for example, word can be represented through like apple can be represented through like 5 5, banana can be 6 5, strawberry 5 4, yeah, something like that. And just like this, right? The whole sentence gets chunked and each chunk is assigned with a numerical value. That's what we call embeddings, vector embeddings. Pawan is a developer evangelist at Single Store. So the whole sentence gets chunked and each chunk is assigned with a numerical value. And all these vector embeddings are stored in a vector database basically for further, processing. So this is so that's how this thing basically works. The external data and the external data splits and it can be any PDF file or document and the data gets chunked and that's how this process is known as tokenization. And like I said, like we saw before, each word is assigned with a numerical number and we call that as embeddings and all these embeddings are stored in a vector database and the there are different ways how the search basically works in Gen AI applications. For example, there is vector search, semantic search, where the context is retained, and like I said, like different sentences, similar type of sentences are grouped together when it comes to semantic search. Like for example, hey, what's up? How Hi, how it's going? Hello, how are you? So as you can see, the second example, I love my dog, I adore my dog, I like my dog. So all the similar type of sentences are grouped together. And again, cosine similarity. This is also one type of similarity search when it comes to Gen AI applications. As you can see, similar, unrelated, and opposite. It's as simple as that, as shown in the image, right? And the difference between traditional versus vector databases. The in the traditional database, the data is stored in row and column format, whereas in the vector databases, first the data gets converted into vector embeddings, and all these vector embeddings are properly stored in a vector database, right? And yeah, this is a simple example of a vector database, right? The structured, unstructured data goes through an embedding model, like we saw text embedding ADA002 from OpenAI. You can also use different embedding models from there are some from Hugging Face, and you can use Cohere embedding model. And then the whole text, the documents, everything gets converted into vector embeddings, like the in the numerical format, and then all these vector embeddings are stored in a vector database, right? And we should also understand the difference between just LLMs and then RAG. For example, you have an e-commerce store, and if you ask a query to the system, what's the average cost of one jeans, right? The LLM will try to answer something generic, right? The cost of one jeans is blah blah blah. But whereas, RAG is where our custom data specifically related to our website is present. So it goes through that specific data, and it will tell you the cost of one jeans on our website is $100. So that's how it usually works. So this is the simple difference between LLM and RAG. So this is the current AI landscape. Currently, there is OpenAI, there is Google, Anthropic, Meta, Microsoft, and Stability AI. These are some of the big names that are producing, coming up with different types of LLMs, right? And this is the cloud AI platforms like Azure, the three big guys, Microsoft, AWS, and Google. And these are some of the key benefits if you use them, like security, scalability, reliability, and cost management, right? And these are some of the LLM use cases. Like we saw, you can use them for content generation, summarization, translation, classification, and to create chatbots, right? And yeah, coming back to single store database basically delivers built-in similarity search on vectors to add memory for your generative applications. By the way, single store started supporting vectors long back in 2017 itself, but because of all the hype around Gen AI, that's where these specialized vector databases started popping up, right? Yeah, so this is a typical enterprise data architecture, kind of very complex. As you can see, there is a in a company, we might see this type of similarity, right? Your customers might be running a lot of analytical workloads, and you feel like having an OLAP database. And after certain days or months or years, you feel like some of your customers are using heavy transactional workloads, and you feel like having an OLTP database. And now suddenly all the hype is around Gen AI applications, and you feel like having a vector database. But if you actually see, maintaining all these databases at different levels is very complex for your data architect or any ML guy or AI guy or even the DevOps guy. So that's where we propose like having an all-in-one data platform like single store, like instead of having a specialized vector database that does similarity search properly, have single store that can do ingest index documents, supports all types of data, does re-ranking, hybrid search, similarity matching, and much more, right? So these are some of the limitations if you just use specialized vector databases like Milvus, Viviate, or Pinecone, right? They have limited SQL support, built only for vectors, long indexing times, no enterprise features, and scalability and performance issues, and different indexing techniques. But single store supports Python, and you can use SQL, and you can do much more. So go to single store. We have a free share tier. Use this link. I think I have shared. I think Yukti is sharing there. And whoever signs up to this, I think tomorrow or after this, you will get an email with with a Gen AI Gen AI for everyone ebook. So I have compiled this properly. I have it's 81 pages. So I'm going to share this. I think Yukti is going to share that with you guys. And yeah, I just wanted to show you guys how single store can be used for real-time dashboard on top of your agentic or AI applications. So I just wipe coded something and this is my whole application code. If you guys can see, I have an application app.py. I mean, it's a simple e-commerce. It's a simple e-commerce dashboard that I have created with Flask, and we'll connect with our DB, and all the logic is already present. I have used Claude to get this thing done. So my intention is basically show you how real-time database, how real-time base, applications basically work. And this is config.py, and this is my data generator py. So what happens? This thing automatically generates data and ingests data in milliseconds, and we can also see how the data gets ingested into our database, and we can basically create a proper beautiful dashboards using single store. So let me run this uh, app and show you guys. So this is running. So let me ingest some dummy data here. So now it is connecting to single store database, and the database connection is successful. And now it should start ingesting data. As you can see, starting real-time sales simulation. It's all a simulation, right? So inserted 10 sales. Last one is yoga mat. So let it insert some more data so that I can actually show you how that thing basically works. So I can go to this particular application link on my local, and hope you guys can see that. So real-time e-commerce dashboard. So you can see in milliseconds it is actually changing. So this is how we can actually build real-time e-commerce dashboard on top of your applications. As you can see, it's all real-time happening, and this is how the data is changing. It is also showing the execution time, right? And it's also showing top products, the revenue by category, and sales in the last minute, and average order value. So it keeps changing because the data is getting ingested in milliseconds, and that's how you can basically create all these beautiful dashboards. So I want you guys to sign up using the link we shared, and then you can actually go to single store, build your amazing applications. So it's not just about AI applications, but on top of AI applications, you might also want to do real time things, right? So you want to see things how they are happening in real time. So that's where single store comes very handy. MongoDB is very, it's not good with real time, but like that's what we say, right? Don't just use specialized vector databases, but use all-in-one data platform like single store. So yeah, I mean, I think I'm almost done. Thanks, guys. Thanks. Let me stop sharing, and if you have any questions.
All right, so we are officially open for Q&A. If the present audience has any questions, please use the Q&A button which is present at the bottom of your console to communicate any questions with us. If not, Pavan, yeah, as you can see on your screen, you can start, like you can sign up. So Pavan, there's one question about the URL for ebook. If you sign up, we can send that ebook to you. So
Yeah,
it would be communicated to you via
sign
email.
up. Yeah, and sign up, or else you can just sign up and also tell me on the, you can ping me on LinkedIn also. So good. So please sign up to Single Store using that link, and I'm going to share that. You can just ping me on LinkedIn, or you have my email. I think we can also share the email if you guys didn't don't receive tomorrow or anytime. You can also Let me share my email, right? If you have any questions, but I want you all guys to go to singlestore.com, sign up. We have free shit tier and create amazing AI applications.
That would be an upcoming thing though, but like I would like to
Yeah.
tell people that are already there. We like our upper management, we are actually planning something that people that actually sign up and they build something, we are giving away gift cards for Amazon. And they would be like uh pretty decent. So like this is like a spoiler to what we are going to do later on. So you might see those things come up in the future sessions. So if you have any ideas, or maybe if you have like any propositions on what you would like to build, you can either reach out to me or Pavan on LinkedIn. And like we're always open to having a conversation even on our Discord channel. Pavan, we have a question from Ishika. She says, what do you mean
Okay.
by hybrid plus vector search?
So there is vector search and there is full text search. One second. So what do you mean by hybrid plus- So both are different. Vector search plus keyword search plus full text search is what we call hybrid search. So vector search plus usually what all Gen A applications go, like the search thing is a vector search, but hybrid search is something only like single store type of companies have, right? So hybrid search is basically keyword search plus full text search, right? So that's how you get a lot of context when you ask a query. So yeah.
And I am done with the announcements. So I think it would be safe to conclude the session. So, folks, thanks everyone for attending. Pavan, do you have anything else that you would like to mention?
You shared the link to all
Yeah,
because
yeah,
they're
yeah.
asking. Okay, okay,
I sent that. Yeah,
got
I sent the link in like personal message as well.
got it.
So right. So yeah, thanks Pavan for your precious time and doing the session with us, and thanks everyone for attending. Have a great
Thanks,
rest of
Yukti.
the day.
Thanks, guys.
Uh, yeah, and you can always, reach out to us about anything that you're building. My DMs are open. If you have any feedback or any questions regarding today's session, please feel free to email. And the recording for today's session, along with the resources, will be shared. And yeah, that email will also mention my email at the bottom. So if you have anything that you want to reach us, reach about, reach out to us, please let us know. And yeah, all right. Thank you, everyone, and have a great rest of the day. Good evening and good night.
Bye bye.
Bye.
Bye, guys.